Hello, this is Miss Jackson. I'm going to make a video now to go over the extra practice for applying multiplication and division day 8. Let's start with problem 1 because there are a lot of blanks there, and that just kind of looks overwhelming, but it's really not if you kind of take it one section at a time. So for problem 1, it says write the multiplication and division fact family for each set of numbers. Well, here's the only set of numbers I have: 6, 48, and 8. And the first problem I need to write is going to be a multiplication problem, and I know that because the operation here is a multiplication sign. Well, if I look at those numbers, if I tried to say 6 times 48 is 8, that wouldn't work out for me. That wouldn't be correct. So my multiplication sentence here is going to be 6 times 8 is 48, and that is right and true and wonderful. The next operation here is a division sentence. So I need to use those same three numbers to write a division sentence. Well, I know that all division sentences start with the total, the biggest number. In this case, it's 48 divided by, I could say 8 equals 6. Looking at the next problem, it's another multiplication problem. My first multiplication problem was 6 times 8. We know that we can switch factors on a multiplication problem, and the product is going to be the same. So I'm going to change the place of the 8 and the 6. 8 times 6 is 48. Okay, the last one we need to come up with is one more division sentence. We know the division sentence has to start with our biggest number, which is 48, divided by 6 equals 8. And this creates a fact family. We're using all the same numbers to create these number sentences. Problem 2. And this one looks a little bit overwhelming also, but it's really not once you get down into it. Write the correct answer in the box. Not all answers will be used. So here are answer choices. If this was a computer assignment or test, they would click these numbers and drag them into the box where they belong. But because you can't do that on a piece of paper, they're going to write the numbers. So we need to first decide which three numbers are we going to use. Which three can we use to create true multiplication sentences? Well, if I try to do 12 times 6, I'm going to get a number far greater than 22 or 2, so that wouldn't work. If I try to do 12 times 2, I would end up with 24. That won't work. So what I'm going to try to do is 6 times 2. 6 times 2 is 12. I know that because we've worked a lot on our times 2 facts, and we're really good at those. Now, beside it, we need to flip these numbers into another true multiplication sentence. And we can do that by just simply switching our factors. 2 times 6 is 12. Beside it in this section, we need division sentences that are true and accurate. We've learned a lot about fact families and multiplication and division. So I'm going to use these same three numbers. I'm just going to turn it into a division sentence. I know that all division sentences start with the biggest number. 12 divided by 6 equals 2, or 12 divided by 2 equals 6. So that completes that problem. Again, if you were on a computer, you would literally have to click these numbers and drag them into the correct blank. So you would want to be very careful that you're dragging into the right spot. Problem number 3. This says solve using the standard algorithm. What number goes in the blank to make the equation true? I'm never going to tell someone they have to use a standard algorithm, or they have to use this method, or they have to use that method. I'm going to tell kids to use whatever method works for you. So today we have 2 word problems, and I'm going to use 2 different methods or we have 3 word problems. I'll use 3 different methods to solve each one. For this first one, I'm going to solve it using the area model. But the first thing I need to do is figure out which numbers to try. I could sit here and ask, how many 9s do I need to get to 153? And I could count by 9s. a lot of times. That's not going to be the most efficient way to solve this problem, though. So that's probably not the way that I would choose to do it. I'm going to look first at my answer choices and see, is there anything that I know isn't reasonable, won't make sense? I'm going to get rid of those. And the first one I'm looking at is A. If I fill in the blank with 161 times 9 is 153, I'm going to ask myself, is that reasonable? If I have 161 9 times added together, am I going to get a total of 153? No, I'm going to get a number that is significantly higher than 153. So I know that A can't be correct. I also know that D can't be correct. I would be willing to bet D would be the most picked wrong answer. And we talk about that a lot in class and why you think someone would pick that. And 100% of the time, someone would pick D 144 because they're not paying careful attention to this symbol. And they would say, well, 144, if I add 9 to that, it brings me to 153. And that is true, but we're not adding, we're multiplying. So D can't be correct. 144 times 9 is going to give me a number far greater than 153. Be careful when you look at these symbols. Make sure you're paying attention to what those are. So now I'm down to two answer choices, B and C, and I can just try them both out. I can do 16 times 9 and see what I come up with. And for this one, we'll practice with the area model. 9 times 16, I need to decompose 16 into 10 and 6, into the 10s and the 1s. 9 times 10 is 90, and 9 times 6 is going to be, what is 9 times 6? 54. When I add those together, we can stack them if we want to in the standard algorithm. 4, 9, 14. 144 is my answer. Well, I needed 153 to be my answer, so this can't be correct. I am not, however, just going to pick C, even though I'm very confident C is going to be the correct answer. I am going to work it out and prove it. So let's create an area model for the problem 17 times 9. Step 1, decompose 17 into the 10s and the 1s, and then move this 9 over to the side. 9 times 10 is going to be 90. 9 times 7 is 63, and if we add that together, we come up with 153, which is the answer we were looking for. So the correct answer here is C. If this is your first video in a while and this area model looks a little bit confusing for you, I have an entire video dedicated to 2-digit by 1-digit multiplication strategies that we've learned this year in the 3rd grade. And the first strategy that we learned is this area model. It's very useful in 3rd grade. I really like it because it eliminates a lot of little calculation mistakes usually, and it gets built upon in future grades and in multiplication problems that are quite a bit more difficult than just 2-digit by 1-digit. You can use an area model for it. They will learn how to do that next year, and it makes the problem quite a bit easier. So it's a good strategy to learn. Okay. Problem number 4. Problem 4 says, last month, Logan worked a total of 28 days. He worked 7 hours each day. How many hours did he work in all last month? Well, the number sentence we would write for this would be 28 times 7. And for this one, I think what we will do is use the partial products method or model to solve this. Partial products is the second strategy that we learned, and it comes right before the standard algorithm. So it kind of transitions us or helps us transition from the area model to the standard algorithm. To solve this using partial products, you're going to take that 28, your 2-digit number, and you're going to decompose it just like we did in problem 3. 28 is going to decompose into 20 plus 8. From there, we need to multiply both parts of 28 by 7, because this tells me 28 multiplied by 7. So when I decompose this, I still have to multiply every part of it by 7. So I'm going to have 8 times 7, because we work in the ones place first. 8 times 7 is 56, and I should have given myself more room to work, but I didn't because there's not a lot of space here. That's okay. Once we've done that, and that's what we just did there, 8 times 7, we need to multiply 7 times this 2, which is really a 20, because if you look over here, this is not just a 2, it's a 20. 7 times 20 is going to be 140. And then we need to add these partial products together. We're going to come up with 196. He worked a total of 196 hours last week. And now, sadly, I'm going to have to erase that because I'm out of space for 5. I really wish I didn't have to erase that, though. Is there a way to move that? Let's find out together. Oh, look at that. Miss Jackson's learned a new trick. That's wonderful. Now let me erase all this that's in the way. Almost perfect. Not totally, but close. There we go. Okay, all I did was take all of this work that was here, move it over there. Let's look at 5. Rodney drives 54 miles each day, traveling to and from work. How many miles does he travel after working 5 days? So our number sentence, if we were going to set this up, our multiplication problem would be 54 times 5. And for this one, we're going to use the standard algorithm. If you're an adult over the age of, probably 18, but maybe a little bit older, this is what you learned, the standard algorithm. We didn't learn area models. We didn't learn partial products. I don't ever remember learning any of that. This is newer. That's newer, but this is what we know. Part of the problem with just doing the standard algorithm is there's not a lot of understanding built into it. It is just straight mimic what somebody told you to do, and it's harder to realize when you've made a mistake. And so that is why we kind of build with those other strategies first to try to develop a little bit of understanding before we go straight into a standard algorithm. So, standard algorithm, we know this. We're going to work in the ones place first. 5 times 4 is 20. Drop the 0, carry that 2, because that 2 is really should be in the tens place because it's 20. From there, we multiply 5 times 5, which is 25, and add this regrouped 2 right here. So 5 times 5 is 25, count up 2, 26, 27. And our total is 270 miles. That's how far he traveled after working for 5 days. Okay, like I mentioned, hopefully in this video, if not the one before, if the area model and partial products is new to you, and it is to a lot of adults, I made a video and I posted it going over those 2 strategies. You can find tons of great videos online. If I didn't explain it clearly enough, you can reach out to me. I will be happy to try to help you with it as much as I can. If not, there are great videos online to help you kind of move through that. I am, again, not going to tell a kid they have to use standard algorithm or they have to use partial products or you have to use area model to solve these problems. Whichever one they're more comfortable with, I'm fine with. If they use area model for everything, that's okay, because that might be how their brain works and how they understand this. If they don't understand area model and they want to use standard algorithm because they're really good at that, that's fine. I'm not going to count them wrong based on they used the wrong thing. And I don't want to say this too loud. I have not yet seen that I remember state tests that require you to use one strategy or the other. Hopefully no one from the state of Texas hears this and gets an idea, because you never know. So they're welcome to use whatever strategy they want to solve these things. Math, wonderful and amazing. Typically one right problem. Lots of ways to get there. Lots of ways to get there, okay? And that's okay, whichever route they're taking. As long as they get to the right answer in the end, we're okay with that. Now, we might try to become more efficient over time and eventually end up here or there. But starting out, if it works for them, if you want to focus only on one strategy, that's fine, because I kind of worry that this many strategies in a row right next to each other can lead to a little confusion. So if they want to stick with one thing and learn that, that is perfectly fine with me. With all of our standards we have to teach, though, unfortunately, we have to teach these things in fairly close together. So I just don't want that to be too confusing. Okay. At the bottom, just as a review, round each number to the nearest 10. Rounding is so new in third grade, and it can be just a little booger. So we want to round this to the nearest 10. We need to see which two tens does this fall between. This is going to fall between 590 and 600. The midpoint would be 595. What's halfway between these benchmarks? And then you plot the number. Well, the number is 595, so it would go right here. Any number that reaches the midpoint always rounds up. So the answer here would be 600. Let's look at 8, because that one is not going to round up. The two tens that this falls between is going to be 30 and 40. And then the midpoint halfway between would be 35. Well, 34 doesn't quite reach 35, so it's going to round down to 30. I haven't seen on a test, on a Starlight test, where they've just asked kids to round numbers. Typically, it's hidden in a word problem, and the word problem will say something like this. So if you want to create word problems at home for your kids and you want them to practice rounding, these are some of the keywords that they will use. They will use the word estimate. So Bob has 599 pears and Jane has 342 apples. Estimate the number, how much fruit they have altogether to the nearest 100 or the nearest 10. Something like that would be fine. If you use the word estimate, that helps. Another phrase is about how many, or the word about used kind of in a rounding way. Isaac has 17 fishing lures. Miss Jackson has 6 fishing lures. About how many fishing lures do they have altogether? And so then the kids would need to round. Another phrase that they use is approximately. And what a word for third grade. Approximately how many this or that's are left, or do people have? Approximately typically tells you to round also. This is good skills practice on how to round, but usually it's going to be hidden in a word problem that says something like estimate, about how many, approximately, or sometimes, not often, it will give the whole word problem and it will say, what is the answer rounded to the nearest either 10 or 100 is usually what we go with. So that is rounding for you. IXL Section T. If you have access to the internet and you want your child to practice, IXL Section T has a lot of good 2-digit by 1-digit multiplication problems in it to practice. And IXL Section U is the division section. So if you want your kid to practice more with some division problems, because we can always use more practice there, IXL Section U is a good place to do that. And if you want to challenge your kid, you can look at problems 3, 4, and 5, and you can ask them, how is the area model like partial products? How is partial products like the standard algorithm? What is similar about the two? What is different? That way they start to make more connections and they can start to move from one strategy to another, or even be pretty fluent, pretty good in all the strategies and pick which one works for them based on a specific problem. Okay, that is this entire page 8, and I think that is all we have for today. Please let me know if you have any questions. I will try to help you as much as I can. I am hoping to have our Unit 5 test, which will cover a lot of this, at the end of next week. I think like next Thursday-ish. Thursday or Friday-ish is when I'm going to aim to have that. I will put out a review and videos for that when we get a little bit closer. Hopefully this helps you a little. If not, let me know. Thank you.